Welcome to Sanjana's Education Strategies. Learn the trade secrets to cover vast concepts in no time. If you like the video, please do like, share and subscribe.
Welcome students. So in this session we are going to see about the chemical properties of acid. Already in my previous video we have learned about the physical properties of acid and also about the reactions under physical properties. So here we are going to learn about chemical properties of acid. So first of all, you should understand there are different types of acids like boric acid, citric acid, carbonic acid, benzoic acid, hydrochloric acid, tartaric acid, acetic acid, nitric acid, oxalic acid and phosphoric acid. So different acids have different functions. So boric acid, it is used as an antiseptic and as eye wash. Okay, as eye wash it is used. Citric acid, it is present in citric fruits like lemon, orange, everything, and also it is helpful in vitamin C preparation. Vitamin C preparation. Remember, citric acid C, vitamin C preparation. Next is carbonic acid. It is used in drinks, beverages, flavored drinks. Okay, like all flavored drinks, carbonic acid is present. Next is benzoic acid. It is also used as a preservation for food. Then for making medicines and perfumes. Okay, you might have seen in some perfumes in that list, you can see benzoic acid will be present. Okay, next is hydrochloric acid. Hydrochloric acid, it is present in our stomach and also it is helpful in cleaning some metal items. Okay. Next is tartaric acid. Tartaric acid, why it is helpful means it is helpful in making baking powder. Next is acetic acid. Acetic acid, it is present in vinegar. Okay, so it is helpful in making vinegar. That is, vinegar is used for cooking. So for cooking purposes, acetic acid is helpful. Next is nitric acid. Nitric acid is mainly used in explosives. Next is oxalic acid. It is used as a ink stain remover. That is, if somewhere ink is stained, to remove that ink, we use oxalic acid. Next is phosphoric acid, which is used as a fertilizers by farmers. All will be using fertilizers. So for that, phosphoric acid is used. This is about the different functions of acids. Now we'll see about the chemical properties of acids. So first chemical property what we are going to see is active metal reacts with acid to give salt and hydrogen. So I am taking an active metal, say magnesium. Magnesium on reacting with the acid. If I am taking HCl, it gives salt, which means MgCl2 plus hydrogen is evolved. Okay, this is one reaction. Like that, some active metals like zinc, ferrum, everything you can take. Next is base plus acid gives salt plus water. This is neutralization reaction. Okay, neutralization reaction. Okay, so base, I am taking a base, say copper oxide. Copper oxide plus H2SO4, sulfuric acid, it gives a salt. That is copper sulfate plus water. Okay, base plus acid gives salt plus H2O. Base, you can use base as any oxide, any metal oxide or any metal hydroxide. Okay, metal oxide or any metal hydroxide. For example, NaOH. It is a metal hydroxide. Okay, now CO3 or HCO3, meaning carbonate or bicarbonate in reaction with acid gives salt plus water plus carbon dioxide. So I am taking a bicarbonate now. Okay, CaHCO3 twice. Okay, calcium bicarbonate plus I'm taking an acid HCl. It is giving a salt, calcium chloride plus water it is giving, and carbon dioxide is getting. Okay, so you have to balance the reaction. Next, SO3 sulfate plus bisulfate. Okay, in reaction with acid it forms salt plus water plus sulfur dioxide. So sulfide I am taking bisulfite. Okay, so I am taking sodium bisulfite. Okay, sulfite. Okay children, sulfite. Okay, I plus acid. I am taking an acid HCl. It gives salt, that is NaCl, normal salt, plus H2O plus SO2. Okay, next metal sulfide. M.S means metal sulfide plus acid gives salt plus hydrogen sulfide is evolved. I am taking ZnS plus a acid HCl or H2SO4. Now it gives salt ZnCl plus H2S. Okay, so you will get this. So this is some reactions based on chemical properties of acid, and there is another one reaction that is reaction with chlorides and nitrates. So listen carefully. Reaction with chlorides and nitrates. Chlorides and nitrates. So in this reaction you have to remember two conditions. One condition is below 200 degrees Celsius. Below 200 degrees Celsius. Another condition is above 200 degrees Celsius. Below 200 degrees Celsius and above 200 degrees Celsius. Now I am taking some active metals like sodium. Okay, sodium. So sodium chloride plus any acid. Okay, I am taking concentrated sulfuric acid. Then it gives NaHSO4. This is acidic salt, meaning it is having hydrogen. Okay, so it is acidic salt plus HCl is evolved. Okay, this is below 200 degrees Celsius. Now above 200 degrees Celsius, instead of acidic salt, it forms a normal salt. That's the only difference. Okay, NaCl plus H2SO4 gives acidic salt and HCl below 200 degrees Celsius, and it gives normal salt and HCl above 200 degrees Celsius. Okay, same thing is applicable for KNO3. KNO3 plus H2SO4 concentrated sulfuric acid, it gives acidic salt KHSO4 plus HCl, where below 200 degrees Celsius. Above 200 degrees Celsius, it gives a normal salt plus HCl. Okay, that's all about the chemical properties of acid. Okay, now we'll see about bases. Okay, now we are going to see about bases. So before seeing about bases, you have to know what is a base. Okay, and about alkalis also we are going to see. So first we'll see what is a base. A base is either a metallic oxide or a metallic hydroxide. It is either a metallic oxide or metallic hydroxide or ammonium hydroxide, which reacts with hydronium ions of an acid to form salt and water only. This reaction's name is neutralization reaction. What is it called? Neutralization reaction. Okay? Meaning a base, let it be a metal oxide, let it be a metallic hydroxide, or let it be ammonium hydroxide. When any of these three reacts with acid, it forms salt and water. Okay, that is said to be a base. And we know already acid, it is having hydronium ion, H3O plus ions, hydronium ions. So this base reacts with this hydronium ions to form salt and water. Now listen, this metal oxide, metal hydroxide, ammonium hydroxide, together we call it as base. Okay, when they react with acid, they can form salt and water. Okay, in this, there are some metal hydroxides. There are some metal hydroxides which are soluble in water. Which are soluble in water. Those metal hydroxides which are soluble in water are called as alkali. Okay, now we understood what is alkalis. The metal hydroxides which are soluble in water. Okay, and they produce only negative ions. Negative ions, that is known as alkali. Now listen, I am taking a metal hydroxide. See an example, NaOH. This is a metal hydroxide which is soluble in water. So in water it produces Na plus OH minus ions. Okay, it produces Na plus OH minus ions. Okay, so this OH minus ion is produced by the base. Okay, this OH minus ion is called as hydroxyl ions. Okay, so we know already acid, it is producing hydronium ions. Yes, we know already that acids, it is producing hydronium ions. Bases, it produces hydroxyl ions. That's all. Okay, so the metal hydroxides which are soluble in water and it gives hydroxyl ions are called what? Alkalis. Are called alkalis. Okay, now listen. The bases which are soluble in water are called alkalis, and these alkalis form OH minus, that is hydroxyl ion, as the only negative ions. As the only negative ions. Okay, now this alkalis, it has the capacity to turn red litmus blue. Just like bases only, it turns red litmus blue. That's about alkalis. So from this, what can you say? All alkalis are bases, but all bases are not alkalis. We know metal oxide, metal hydroxide and ammonium hydroxide are bases, but only the metal hydroxides which are soluble in water are alone what? Alkalis. Okay. So all metal oxides and metal hydroxides, all metal hydroxides and oxides are not soluble in water, but there is an exception, except sodium, potassium, calcium, ammonium. These four are soluble in water. These four are soluble in water. Their hydroxides are soluble in water. So, sodium hydroxide is soluble in water, potassium hydroxide is soluble in water, calcium hydroxide is soluble in water, and ammonium hydroxide is soluble in water. That is the meaning, which means all these are alkalis. I told you already, the metal hydroxides which are soluble in water are called as alkalis. These four metal hydroxides are soluble in water, out of which first two are said to be strong alkalis. Okay, last two are said to be weak alkalis. The reason is, first two, that is sodium hydroxide and potassium hydroxide, they completely dissociate in water. But calcium hydroxide and ammonium hydroxide, they are not completely dissociating in water. Okay, they are just partially dissociated. That's why they are weak alkalis. Understood? First two are strong alkalis, first two are weak alkalis. Understood? That's it about alkalis. And another one important thing, just it's an exception, or I told you already, all bases are not alkalis and all alkalis are bases. So example is, you can see iron hydroxide or ferric hydroxide, copper hydroxide or cupric hydroxide. They both are bases, but they are not soluble in water. I told you already, all metal hydroxides and oxides are not soluble in water except this 4. Other than this 4, all are not soluble. Only this 4 are soluble. That you have to keep in mind. Okay. Now